Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Diamide, N2H2, sometimes written loosely as N2H4 in certain texts, but the active species is diamide N2H2, is a highly selective reducing agent. Concept: diamide reduces nonpolar or symmetrical double bonds via a concerted S-Y addition mechanism. It delivers two hydrogen atoms simultaneously in a cyclic transition state to pi bonds that are relatively nonpolar. Reasoning: A, C is equal to O is a polar double bond. Carbonyl diamide does not effectively reduce polar bonds because the cyclic transition state is not favorable for electronegative heteroatom-containing bonds. B, CN, nitrileimine, is also a polar bond involving nitrogen, and diamide is not used to reduce CN triple bonds. C, NO2, nitro group, is a polar functional group. Diamide does not reduce nitro groups. D, CH is equal to CH, alkene, carbon-carbon double bond, is a nonpolar, symmetrical double bond. Diamide selectively reduces C is equal to C double bonds, alkenes, through a concerted, SYN, pericyclic six-membered transition state in which both hydrogens are delivered to the same face of the double bond simultaneously. This selectivity for nonpolar pi bonds over polar functional groups is the hallmark of diamide reduction. Why other options fail? Carbonyl, nitrile, and nitro groups all contain electronegative atoms creating polarity. Diamide's cyclic transition state is geometrically and electronically suited only for relatively symmetrical pi systems like C is equal to C. Therefore, the correct answer is D. Therefore, the correct answer is option D.